Hey, triangle proportionality theorem and its converse. So we've been doing a lot of geometry lately, but we've been kind of light with the algebra, so let's see if maybe we throw a little bit more algebra in today. This will be kind of fun. Okay, so we're going to have a triangle. And then we're going to have a line parallel to one side of the triangle intersect the other two sides. Right, so in the diagram, if segment TU is parallel to segment QS, then we know the distance from R to T compares to the distance from T to Q the same way that the distance from R to U compares to the distance from U to S. It should be fun and exciting. The converse, well, if you already know the ratios form a proportion, then you can conclude those segments have to be parallel, right? So if I know the segments are parallel, I can then move on to the proportion, or if I start out knowing the proportion is true, I can then conclude that the segments are parallel. We're obviously going to spend much more time with the original theorem and not so much with the converse. Okay, what would be the length of segment RQ? Well, I know RQ compares to QU in the same way that RS compares to ST. Substitute in the values I know. Cross multiply. Looks like I better divide each side by 6. And the distance from R to Q is 6. Simple enough. Don't be surprised when you see some X's appearing on the worksheet, though. You might have some fun with some algebra. The IXL for today is P5. Similar triangles.